Hello guys, my name is Ganesh and today in this video we are going to solve problem of the day on GeeksForGeeks platform. So without any further delay, let's get started and try to understand the problem and what kind of data structure we can use to solve that problem. So without any further delay, let's jump onto the problem. So problem is saying that we have given a DQ, that is double-ended queue, containing non-negative integer along with the two positive integer type and k. So our task is to rotate the DQ circularly by k positions. So there are two type of rotations we can see that in this problem, right rotation and left rotation. So right rotation means clockwise. If the type is 1, then we need to perform the right rotation. And another is left rotation, that is anti-clockwise. If the type is equal to 2, then we need to perform the left rotation. So what does it mean, left rotation and right rotation? So right rotation means that we need to rotate the DQ to the right. It means that moving the last element to the front and repeating the process k times. On the other hand, left rotation means anti-clockwise, uh, means that rotate the DQ to the left. This means moving the first element to the back and repeating the process k times. So let's try to understand using an example. Suppose that this is DQ and type is equal to 1 and k is equal to 2. So yes, so DQ is this and we need to rotate, we need to perform the rotation right, means clockwise, and 2 times. So after at the end we will get the output something like that. Okay. So this is second example and type will be 2 and k is equal to 3. It means that we need to perform the left rotation and output we will get the output something like that. So these are the constraints. So complexities. So time complexity is of order of n and auxiliary space is order of n. It means that we cannot take the additional data structure to store the result. We need to perform by the order of 1. And the topic tag is data structure and DQ. If you know about the DQ data structure, then you can definitely solve this problem. If you don't, simply search the DQ data structure and methods. Because this problem can be solved the DQ data structure methods. So this is the definition of the DQ data structure, that is double-ended queue. It is a linear data structure that allows element to added and remove from both ends. So this is the property of the DQ data structure. And the common methods is these things, and we have to use these methods in Java. So yes, so these are the method that is going to be used in this problem. So you can see these things. So yeah, let's jump onto the problem. How can we solve this thing? So I will just maximize my screen. So problem is saying that if type is equal to 1, then we need to perform the right rotation, and if type is equal to 2, then we need to perform the left rotation. So first of all, I will write the logic of this thing. So if type is equal to 1, then I will perform the right rotation, and I need to pass the DQ and the k value. Otherwise, I need to perform the left rotation, DQ and k. So this is simple logic. If type is equal to 1, then do this thing. If type is equal to 2, then do this thing. So I need to put the logic and idea these two methods. So I will make first private static void and this method right, and this would be DQ of integer DQ and int k. Okay, so I will write the code for the right rotation, and the left rotation code will be the same, this one. So first of all, I will check the length of the DQ. If there is only one element, then there is no need to rotation, something like that. You can understand this thing. So n DQ dot size is the method by which we can find the length of this DQ. And I will check firstly, if n is equal to 0, there is no need to do anything. I will return simply. Then I will do the normalize of the length of this DQ data structure. For that, what can I do? I will do something like that. If the K is greater than N, then I need to normalize this thing, no? So N. Then I will do this thing, process the K times. I need to do rotation this K number of times. So I will use the for loop. I is equal to 0, I is less than K times, and I plus plus. So we are going to perform the right rotation. It means that the last element of the front to the front, last element to the front means that I will take the last element. I will take the last element. So how can I do that? So I will go to the this method, that is remove deletion. That is remove first. I will copy this method and paste it here, something like that. So in this last uh, variable, we will get the last element. We will get the last element. Sorry, this is what last element. Remove uh, last element. Okay, and we will put this element to the front. So for that, what can I do? Du dot add first. Simply add this last element to the first. So yeah, this is the logic of the right rotation. I will copy this method and paste it here, and I will do the left. Similar this thing, I will check the n size. If n is equal to this thing, then return. We will normalize these things, and we need to change only these things. What moving the first element to the back. So we can get the first element from the DQ and put the last onto the last position, this first element. So yes, that's it. That's it. Now you can see that this is the simple logic which is going to be described in this problem, and simply we read and write the code. So when I compile and run this, so there is a problem, DQ dot add list, not list, it is last. Last. Okay, so this is typo mistake actually. Yes, you can see that. Submit this code.